we have Bill Gaines, who worked with the Forest Service for a long time and now is an independent wildlife ecologist in the general Wenatchee Leavenworth area, but he worked much broader, more broadly than that. And then after Bill, we have Ken Bevis, who is a local here, who works in the DNR as a stewardship wildlife biologist. And I think we'll just straight on to their talk.
So yeah, I'm Bill Gaines. I'm a wildlife biologist. I worked for the Forest Service. Actually, in the 1980s, I lived up here in the Methow Valley. I was a wildlife biologist for the Forest Service at the Winthrop Ranger District. In the early 90s, I transferred to Leavenworth area and became a wildlife biologist on the, at that point, it was the Wenatchee National Forest before it was combined. So many of you experienced quite a crazy summer last summer. And the summer that was sort of our equivalent was the summer of 1994. And that year, my wife and I have a house a little ways up the icicle. We were working for the Forest Service. We had a fire that started in the icicle, and it came out the mouth of the icicle with a huge wind behind it. And it was a crazy year, just like you experienced. We had multiple fires. We had fires all around us. We actually we were working, but we took all of our stuff out of our house because we were on a level 1 and level 2. So it was I can totally relate to what you're experiencing here. But that year really it opened my eyes to a number of things. And one of those was the relationship that fire plays with wildlife and wildlife habitat here on the east side of Cascade. I know there's been a number of folks talking ahead of me, like Paul Hesberg and others, about fire regimes and fire ecology and the role that they play in aquatic and terrestrial ecosystems. But what I started to realize was that to really be an effective wildlife biologist on the east side of Cascades in this fire-prone environment, I had to be just as good at fire ecology, because the fire and the interaction between fire and vegetation form the template upon which the habitats exist in the east side of Cascades. So that's what I'm going to focus on, is sharing with you some of that background. I've been fortunate to work in both the management and research side of the Forest Service, which has allowed me to do some research on the effects of fire on wildlife, and I'll share some of that with you. I'm going to give you a little bit of background review, context, if you will, about fire. Quite where to stand. About fire regimes and how wildlife are adapted to those fire regimes. I won't go into a lot of depth about fire regimes, but I understand you've already heard that before. But I'm going to focus on the wildlife aspects of that. I'll then talk about how regimes have been changed as a result of past management and how they're likely to change as a result of climate change, and how those are working together to create a really different kind of disturbance ecology and wildlife habitat pattern than what was there historically. I want to then, I'm going to spend a fair amount of time here kind of going over some general patterns and specific species. But I want to leave you with kind of the last half of my talk talking about what do we do about the changing fire regimes? How do we treat the forests and the landscapes to better accommodate wildlife habitat, wildlife populations, but also address some of these concerns about altered disturbances? How do we focus on restoring parts of the landscape that really matter for wildlife? I'm going to share with you some of the research that we've done on how these kind of these restoration treatments are really ways that we try to mimic the natural fire that would have occurred out there, and what does that mean for wildlife? I'm going to focus specifically here on birds, and then I'll talk about a strategy that we've been working with to try to restore the forest, restore some of these patterns of these habitats, and how we then integrate wildlife habitat with disturbance ecology to create a landscape that's more resilient to this kind of crazy future that we're likely to experience. So let me start here with a little bit of overview about fire regimes and fire ecology. We're really lucky here on the east side of Cascades, on the Okanagan, Wenatchee area. We have a lot of fire history work that's been done for several decades. In fact, I would venture that we have more fire history studies here than anywhere in the inland west. These forests have been really, really well, they're fairly well known now in terms of the kind of ecology, the fire ecology that happened historically, and how that pattern has changed over time. So you may have seen, this is just a very simplified example of the kind of fire disturbance patterns that we see on the east side of the Cascades. So this would be the crest of the Cascades as you move eastward out towards the Columbia. These patterns of forest type, habitats, and fire ecologies change as you move both to the east and down in elevation. The high severity fire, which forms a really important type of component for certain kinds of species, which we'll talk about here in a minute, very important for certain kinds of wildlife. High severity fires are typically very, they're a standard replacement. They kill a lot of trees. They result in major changes in the patterns of vegetation. You move down in elevation and you get to more of the mid-elevation forest types where you have things like Douglas fir, maybe a little bit of farms of pine on the lower end of it. That area is really pretty complicated in terms of its fire ecology and also complicated in terms of the habitat patterns and what that means for forested wildlife species. And again, we'll talk about some of those situations as well. And then you get down to the lower elevation, kind of the fringe of the forest landscape, where it interacts with more of the grassland or shrub steppe habitat. These were characterized by kind of forest with more of an underburn, low severity type of fire, a lot of fairly open kinds of forests. The major change that has occurred here on the east side is that this mixed severity fire has actually moved down the hill. It's moved well into the fire ecology of the lower elevation pine forest, to where this area is now formed a very fairly large zone that acts a whole lot more like a mixed severity fire kind of regime. And that has a lot of implications for wildlife habitat, tremendous implications. So as I put this talk together, it is a tremendous challenge to, in 45 minutes, tell you how wildlife and fire interact. It's really challenging. And the reason is, there's like 400 and some vertebrate species that you could talk about. And each of them have different life history pattern that allows them to do different things in fire. They react differently to fire. In addition, fire in and of itself, we like to lump it into high, mixed, and low, but in reality it's really messy. You know, it depends on whether you're on a north slope or a south slope, or whether it rained the day before, or whether it was, the wind was blowing. All that stuff affects the type of fire behavior that you see on the landscape, which in turn affects how wildlife react to the fire. So what we're kind of stuck with, if you will, is talking about some general patterns. So what do we generally see when we see fire happen on these landscapes? And so what I want to do is share with you the general patterns, realizing that for every generality in wildlife, there's always a number of exceptions. That's just how it all works out. But share with you some of the general patterns. And then what I want to do is go in and show you some specific examples using some of the wildlife species that we know and love from this area. So let's talk a little bit about this. So generally, wildlife that live in frequent fire environments have strategies that allow them to minimize the impacts or adapt to those changing environments that fire creates, so that we minimize, usually, a population level. Now, that's not always the case. As I showed here, there's some exceptions. But generally, wildlife have adaptations. They can run, they can fly, they can burrow on the ground. They have ways in which they can escape direct mortality from a fire. Now, we know that's not always the case. We know that there was a wolf that was killed by a fire. I've seen situations where deer have been killed by fire. There are exceptions, but generally it doesn't really result in a large effect to the population, at least from the direct effect of the fire. There are some exceptions. Probably the group of species that are most vulnerable, if you will, to a fast-moving fire are those that aren't very mobile and and that are living above ground. And I'm going to show you an example of a not very mobile species here in a minute that's adapted away dealing with fire. And then the other thing that that creates a situation where wildlife are susceptible to disturbances like fire is when populations are small and they're already at risk. You can think of western gray squirrels or sharp-tailed grouse. Populations that are already naturally fragmented and small, they can be susceptible to these kinds of things. Generally, species that are associated with close canopy forests decline, or at least their habitat does, following high-severity fire. That seems to make intuitive sense. And those that are open forest species generally benefit. Species that are associated with snags generally increase. And then the species dependent on shrub and herb understory generally benefit. This latter one might take a few years, but generally what you see is fire sort of creates a rejuvenated understory where plants come in that may have been there in terms of their seeds may have been in the soil, but they needed fire to sort of get them going again. And you see this big flourish, especially 2 or 3 years after the fire, of plants that you see that you might not even know were there before. You really get a real flourish in those understories in those cases. So those of you that, like me, that are data nerds, here's another way of expressing some of those generalities. So this is what this shows you. This is a whole bunch of wildlife species that live on these slides. There's like 250 species that are captured on this slide. And what really the story here is that in the Ponderosa pine forest, where you generally get low severity fire, and you get this mix of early, mid, and old forest. That's what the colors are showing you. In the east side mixed conifer type, this is sort of that mid-elevation mixed severity. And then these are your higher elevation forests where you get the high severity. Now, if you were in an environment in which fire was not very frequent, you would expect, and what this is showing you is the proportion of wildlife species that breed in these different forest types. Is where they find their breeding habitat. And there's multiple species that breed in multiple types of forests here. So that's why you see the percentages that don't add up to 100. But really, the take-home message here is that if you were in a type of environment where you didn't see a lot of fire, you would expect that the wildlife species are very well adapted to living in the old forest, but not these other younger forest types. And you can see here that across all these forest types and all these different fire severities, we have a lot of species that breed in all these different types. So they're very flexible, they're very adaptable to a constantly changing type of habitat. And that's really what that's getting at. It's trying to get at, if we have wildlife here, are they really adapted to these fire-prone forests? And the answer is, at least in terms of breeding habitat, is yes. They have a life history that allows them to do well in those mixed types of forests, mixed age forests. Okay, now let's dig in here and talk about some wildlife relative to just the high severity. And I'm going to start here with a very highly mobile species, Canada lynx. This is some of the fires that burned up in the Pacific. Canada lynx have a life history that allows them to use a whole host of different age forests, and they use those forests for different parts of their ecology. This fire burned pretty hot up this drainage, and lynx, we're learning from some work that's going on in this part of the landscape, actually, in tracking lynx, that these big open areas where these big burns occur, lynx will actually avoid crossing those, and they're going to use these landscapes out around the edge. And they're going to use the edge that is created by fire to hunt in and to forage along. So that pattern that those landscapes create, that fire level landscape creates, this pattern of different mosaics of different age forests is really key for lynx, because they find different components that they use. For example, I talked about the earlier younger age forests where they forage in, and then in the older, on kind of the opposite end of the spectrum, are those areas that don't get, maybe they have a skip of fire. They're the riparian areas where it's a little more moist, and the fire might skip over the top of those. And maybe the wood that comes down from the previous fire creates a really dense pocket of thick trees and thick down logs, and that's where those lynx will have their kittens. So different parts of the landscape, whether it's young or old, or kind of even age in between, these different parts of the landscape create this mosaic pattern that lynx use for different parts of their life history. This slide here is actually a burn from 1970, so a lot of the trees were of a very even age, about 40 years, and a second fire came in about 10 years ago and burned it again. You can see the different patterns that are across that landscape. Down here are some larger trees where you might find some of the more denning type habitat. And then this stuff is about 40 years old. Good stuff for snowshoe hares where lynx might forage. And then this young stuff is going to create kind of the replacement habitat eventually where those snowshoe hares will take advantage of that forest as it develops. So lynx is a really good example of a landscape level species that uses these high severity fires, and the patterns that those high severity fires create are very, very important to the lynx. High severity fire also creates just a big pulse of habitat for snag-dependent species. Blackback woodpeckers and three-toed woodpeckers are a couple of species that we refer to as fire dependent. We don't really understand exactly what goes on here, but we do know that after a big fire, and it happens fairly quickly after a big fire, we see these birds. These are a little woodpecker, 6 or 8 inches long, all black in the back. This is a blackback. They, for some, I don't know how the word gets out on the airways, but somehow they communicate, and they communicate from a long ways away, because all of a sudden you'll see significant increases in these woodpecker populations in these fires. They usually peak after a couple of years. It takes a little while for once the dead wood is on the landscape, it takes a while for the insect numbers to build up, and that's usually a couple of years. I remember walking through this forest after a forest like this after the 94 fires. It had been the summer following the fire. So the fire would have been a year old, and you could literally hear the insects crunching on the wood. It was so loud. It was very obvious. Yeah.
So we know for a fact that those blackbacks and three-toads migrate in from somewhere. They're not born there.
That's right. So what we know is that when it's a green forest, they're there, but they're there in really low numbers. And we actually don't think there's enough of them in those green forests to really make it in the long term. They got to have this concentrated habitat to build up their populations so that they can hold out until the next big fire comes in. Really pretty cool. So as a forest succeeds after fire, there's a whole host of things that happen with the dead trees, but there's a whole host of things that happen with the birds as well. And I want to kind of explain this a little bit. So you can imagine a fire happens here. And what this line is, these are the snags. This is what happens to the snags over time. What you see actually is right after the fire, there's some trees that haven't made up their mind whether they're going to become snags or not, right? Some of them are sort of partway burned, but they're not all the way burned. And some of them will actually recover and do okay. Pontus and pine are really good at that. But things like grand fir, if they smell smoke, they're dead. So it just depends on the ecology of the tree. But you'll see a gradual increase as the delayed, what we call delayed mortality takes place. And that can be a result of the tree just dying from the fire, or it could be a result of what happened with the insect. About a couple of years after that fire, your snag numbers are going to peak. And they're going to stay really high for about 10 to 15 years. You're going to start seeing a significant decline, especially in the smaller size plots, the smaller trees. And in that period there, this is when blackback and three-toed make their living. This is when they are primed, they got lots of good food to eat, they come in numbers, and they show up and they really take advantage of this situation. As time goes by, so the other thing these guys are doing, they're what we call primary cavity activators. And they're drilling holes, and they're drilling cavities, and they're creating nest sites for what we call the secondary cavity nesters. And they come in right on the heels of these primary cavity educators. They nest in the cavities that are used by these. Now the snag numbers start declining. And as these numbers decline, these guys disappear. They go somewhere else. They go somewhere where there's more snags and more food. Yeah, now as that declines, however, there's a whole growth of shrubbery that comes in, right? And the real story of where the bird community comes after a fire is in the shrubland. All those birds that nest on the ground or in the shrubs become really prominent. As you get out here about 5 to 7, 8 years, they become much more prominent. The other thing that happens is this other bird comes in. It's this bird called the Lewis's. It doesn't feel very comfortable when there's too many snags around it. It feels all closed in. So as those snags fall down and it opens up, the Lewis's woodpecker will come in. And they're a pretty good sized, they're a pretty good bodied sized bird. So you got to have some of those big trees that stay standing for them to have a nest, to create a nest. So that's sort of the succession that happens over time with snags and birds. And you get out here, I've seen these Lewis's woodpecker still nesting in fires that occurred in the late 80s. So they can hang in there for quite a while. And this is just, again, for data nerds like me, the small trees, these are how many trees were remaining after 10 years. This is how many trees, the percent of the trees that fell over after 10 years in our monitoring study. So if you're a small tree, you fall over pretty fast. If you're a medium-sized tree, a little better. And the bigger trees are really the ones that are going to hang in there and survive till the next forest grows. They're going to be kind of the remnant of the dead wood that's still standing when that new forest grows up 30, 40 years later. Okay, so that's the high severity. Now let's talk about mixed severity. Mixed severity is vastly complicated. And the reason it is because you have some low, you have some high, you have some sort of in the middle, all on the same landscape, kind of this pattern across this landscape. And this is a good time to talk about the difference between, or how a closed canopy forest species react in these mixed severity landscapes. Things like goshawk. I'm going to talk about goshawks and spotted owls here for a minute to talk about the example and the life history that allow these animals to do well in mixed severity landscapes. Both goshawks and northern spotted owls forage over vast areas. Their home ranges are large. And as a result of that, within that home range, they have a whole diversity of different forest types that occur within that home range. Now they both, where they nest, they both like pretty close canopy forests. Like a forest that has a large tree to it, some large trees in it, and it has a second layer or sometimes even a third layer of forest that develops under it. That creates really good habitat for goshawk and spotted owl. The other thing that goshawk and spotted owl, especially on the east side, enjoy is they like mistletoe. And mistletoe is highly flammable. It'll just whoosh and it's gone. So these forests that these two species really enjoy are also forests that are highly flammable or highly susceptible to high severity fire. So it's going to that kind of habitat is going to move around the landscape as fires occur. So that's why as an animal that forages around a large landscape, they can take advantage of the fact that the fire is going to change how things are on that landscape. So they nest in habitat, something like this. Goshawks will build a platform on top of a mistletoe clump. They will use that. They will then abandon it. And northern spotted owl, I think something on the order of 80% of our spotted owl nest sites on the east side are goshawk or formerly goshawk nests that were abandoned by goshawks. And those spotted owls can take advantage of that. So here's what we know about things like goshawks and spotted owls and how they use these landscapes. And remember, these mixed severity landscapes are a mix of early, really young forests and old forests and all kind of in-between forests. So they're a real mix of these different fire severities. And what we've learned is that different types of habitat are created for those different types, for those birds. For example, they will forage in a wide variety of fire severities, from low to high. As long as the patches aren't too big, they'll forage through or on the edge of those things. So in terms of providing foraging habitat for them, you can get a real mix of types of forest severity or fire severity. Now, in terms of roosting habitat, now that's a little different. They like a roosting habitat with a little more closed canopy, a little more structure to it, a little more, in other words, a little larger tree size. But they're not going to be quite so happy foraging, roosting in a high severity patch. But they're going to be pretty comfortable where you got something that's a little less severe. And then in terms of the place where they're going to nest, you're really probably only going to see that in low severity where it really hasn't removed a lot of the overhead canopy. A lot of the trees don't die because of the fire, maybe some of the smaller understory. But you can see here how across the landscape, imagine this network, this patchwork of these different forest types. These animals, by sort of thinking about how they use those different types of structure, they can make their living on these landscapes because they occupy such a broad range of conditions. Okay, now let's move down in elevation to the low severity fire. Talk about a couple of species here. So this is probably the environment that historically was the most stable. And by that I mean, when fire went through these environments, it created much less change than it did when you're talking the mixed or the high severity. It actually it was a way of maintaining the open structure of these forests. And that's pretty important because it creates enough growing space for these trees to become large. And I can tell you that there are very few places that I've been on the east side of Cascades where we have truly large trees left. I can think of about 5. I'll show you a picture of one here in a minute. These trees, which are probably 20, 25 inches, they're small in comparison to what we have historically. They look big to us now, but they really weren't compared to what we have historically. But they create these open canopy forests. They create a lot of space. Within this stand, there's actually quite a bit of diversity. There's little openings, and there's little clumps of trees, and then there's some fairly sizable gaps. And those things create nesting areas and foraging areas on a really small scale for things like white-necked woodpeckers and western gray squirrel. Those species are pretty highly adapted, their life history, to these kind of environments. And these are probably, like I say, they historically were the most stable, but they're also currently the ones that probably have been most altered. Their disturbance ecology is so very much different than it was before. And lastly, just briefly want to touch on a couple species from the shrub steppe, grassland shrubland. I know that sharp-tailed grouse is an example occurred here in Methow historically. Likely there will be some benefits of fire as the habitat recovers, especially riparian habitats. It might take a while for the shrub steppe itself, especially the shrub component, to recover. A lot of that depends on what happens over the course of the next year in terms of especially summer precipitation. And probably one of the greater issues with fire in these low elevation habitats is the prevalence of cheatgrass. Cheatgrass comes in, and then the fire regime is quite different than it was historically because of the fine fuel that